Hi everyone. This is a summary of the whiteboard to give you an idea of what we had on the notes. CIS-332, database, and SQL. This is week 2, so this was Monday, so we have some slides on Monday and some slides from Wednesday. So we followed up on Monday with what we talked about the previous week. We just had one day on Wednesday. And we talked about the example of a school converting data into information. So we looked at different ways. For example, here's an instructor table. Call that an entity. And these particular fields that represent these attributes or fields that represent that particular table, the instructor table. And then we have some data elements in here that we filled in. This would be a record. We talked about fields and attributes. So we can have unlimited number of records. We usually have to start off with, a finite number of attributes or fields. The order doesn't make a difference here or here. So we had these entities, and then we did the school scenario. Okay? So then we had what term it was, and we had the term ID, and then we had another entity representing the students, and we'll show those here in a second. Alright. So, we had a student table, a term table, grades table. We had a table here for the course ID, student ID, term ID, grade ID. So we had all those primary keys. Primary key, unique number that identifies. Here we had CIS-332. And then we use this example of these particular entities that represent different parts of the school database. And then we talked about foreign keys. Okay, so here we have a primary key that's in another table, so that's a foreign key. We have the class, another table, that's a foreign key. And the same thing here. You know, which term we have the student, yeah, the class. And then here's, like, for example, here's another foreign key that came from the instructor table. Who's instructing the class? And then we did the example. We had 007s instructing the class. If something happens to them, then we have Agent 99 now instructing the class. And we also did this, you know, instead of having redundant data, for example, if this school was a school, let's say in Mason City, a lot of the addresses here, like NIACC, Mason City, Iowa, this would all be redundant. Mason City, Iowa 50401. So instead, we made a location ID. Here's a primary key. Up here would be a foreign key. So what we listed here, 001, so that represents Mason City, Iowa 50401. And they say one for Clear Lake. And so we can have all of our locations here and then just put the ID in up here. Just look how much we save on data redundancy. Plus something simple, let's say the zip code for some reason changed in a town. You could change it once here, and now it's reflected in all of the locations wherever it was represented. Which really makes sense. You know, over here we have a course ID, you know, right here, 332. If something changed in the course, we just could change it in one place, like here where the instructor changed, and now it affects all the tables that have that in it. Like over here and so forth. Alright, so that's why we call it a relational database. And when you put that all together, you have a database management system. Alright, so let's move on. Here we talked about the internet. We talked about, for example, we gave the example of Power School. A lot of high schools now use Power School, in which all the data is stored there. So here, you could have any school, any high school, or K through 12, they connect to the internet, and they store their information here. And you can imagine all the different tables and so forth there, representing all the different schools. So they can spend X amount of dollars to develop this, and then if they can get enough schools, they can keep the costs down per school. Like WebAdvisor, that's actually stored right at NIACC, about $750,000 for that software. And that's used in a lot of colleges and universities, but it's still expensive. How does that work? So in a cloud, you can have this database. You can have the physical database, how it's actually stored on the disk, logical database, how we can see that database. MySQL is the engine that manages that. And so the apps coming in and looking at that, all they have to do is use SQL to access it. So they just need to know SQL. They don't have to be tied directly to the software that the database is used to get the information on off the disk. Talk more about that later on. Alright, so this is when we started on Wednesday of last week. I think that would have been the 27th, I believe. And we started out, we gave the clinic example, and we said, what entities? And you worked in groups and tried to think about, you're going to keep track of records at a medical facility, a clinic. We came up with doctors, clients, appointments. We talked a little bit of the doctor-to-client relationship. So we came up with some primary keys. And what we really want to do is distinguish between entities and attributes. When people start thinking of situations, they tend to think of the attributes or the fields first, rather than coming up what main entities do they have. So that's something to practice every time you think about a database. Think about what entities or tables you would build, and that'd be the first thing to try to determine. And then from there, you can start putting attributes with those entities. More on that later. So we also talked about then an example like here at NIACC. We have the work server 2. We talked about those data types. That's actually, you go from entities. Once you get entities, then you go to attributes, and then the attributes you have to indicate the data type, and then you start building the relationships between the tables. So we talked about here at NIACC, we got router, got some fiber connected to a router, got multi-layered switch in our room, or switch, and then we have that work server 2 in the room, and we have a database on there. And I can be home, and I can use a browser, and we demoed a little bit of that in class. Look at that, Michael, go to this website sitting on that server, and from here I can actually use the browser to access some data on and off of that website. And we do that all the time. Talked a little bit about the logical view and how the data is actually stored on the disk, the physical. Then we have this conceptual view out here that we might start referring to and talking about the user, how they look at the data. We use MySQL, a particular database management system, to store the data. Work server 1, that's actually connected in right up here like this. Got a letter, bits, so we can store text, numeric, date, video, picture, audio, all these different things that can be stored physically on some kind of storage device. And then we can use this to access that information. And before we get done with the course, you'll understand how to use a browser, write some software. That'll allow that browser, through the browser I should say, allow you to write and retrieve information off of that database. Then the other day we did some work logging into the machines. I talked about using a database. We talked about, this was a simple SQL statement. Here we're qualifying, this is which database and which table. These are the attributes or the fields that we want to look at. And we talked just briefly too, when we did a little demo. You have the SQL and your database on a server, and you have your web access here. You access the web through a demilitarized zone here. This can go in and get the data, bring it back here, and then send it back out through that firewall. In client-server environment. Well, that's it for whiteboard review for this week.